I just finished grading your quiz number 5. Now I'll try to make the tutorial for quiz 5 because I understand that you have to take the exam 5 the day after tomorrow. Well, actually tomorrow because it's I don't know 4 in the morning, I guess. So problem number 1. I gave you 8 problem. I'll try my best to finish 8 problem in 8 minutes. So problem number 1. So the two boxes on the table, box mass 1, 12 kilogram, connected by a rope, mass 2, 10 kilogram. You pull it by 40 Newton. Find the tension force. No friction. Okay, so how are you going to do it? Well, by free body diagram, Newton's second law, that's it. So this is FP, this is FT, this is FG, this is Fn. So F is equal to ma, of course, at the x direction, nothing going on at the y direction. Nobody is accelerating at the y direction. This is m2. So Fp minus Ft is equal to m2a. Okay, so that's it. That's it. That's good enough. So let's come over here. M1. M1, what's going on? Tension force. No friction. Fg. Fn. Okay, so Newton's second law. F is equal to ma. Again, what direction? X direction. What type of mass? Mass 1. How many force acting at the x direction? Only one. Ft is equal to m1a. Very simple. Plug in over there. Fp minus m1a is equal to m2a. So Fp is equal to m1a plus m2a. So a is equal to Fp over m1 plus m2. Hopefully you see it, right? Yeah. So Fp is 40. 40 divided by 22. 10 plus 12, 22. 40 divided by 22. Now you want to see what is the tension force because that's what I asked you to find. So Ft is equal to m1. m1 is 12. 40 over 22. Okay. So 12 for 40 over 22. That's this is 11. This is 6. 240 divided by 11. So 11 goes to 24 twice. Okay, 2, 20. All right, so about 22. Okay, so this is 22 Newton. Problem 1 was 2 boxes on a flat surface on a table. The problem 2 is 2 boxes on an incline attached by a rope. Okay, so let's draw it. This is our incline, 30 degree. Box 1 is 2 kilogram attached by a rope. There is a pulley, and this is mass 2, which is 2 kilogram. Mu k is 0.1. We want to find the acceleration. Let's do the free body diagram. So the free body diagram tells us, let's do the free body diagram over here. So I have to, let's do it over here. So it's going to be easier. So I have 2 kilogram or mass 2. This is m2g and this is ft. There is nothing going on over here. So F is equal to ma at the y direction. So I have Ft minus m2g is equal to minus m2a. Minus is because it's accelerating downward. All right, let's go this one. I have to draw a 30 degree, and then I have to draw this box. Now I'm going to erase this. So now I have what? This box over here. So this is Ft. This is F, let's say Fg parallel. This is Fk. What's going on? This one is perpendicular, so that must be Fg perpendicular, and that must be Fn. So we need all of them, but most importantly we need these two. We're going to call this one x-axis to serve our purpose. So we're going to write f is equal to ma. What direction? At the x direction. It's not definitely x, but it's tilted x. So ft, we're going to call this one acceleration positive because this is positive, this is negative. Okay, just to serve our purpose. If we call this is positive, this one has to be negative. ft minus fk minus fg parallel is equal to m1a because this is m1. In this case, m1 is equal to m2. So even we make some mistake, the mass is same. So, but if the m1 and m2 are not same, then that would be more difficult. Hopefully, in exam 5, I'll make it a little more difficult. Okay, so ft. So what is ft? ft is m1a plus fk plus fg parallel. Okay, what is ft over here? ft is m2g minus m2a. Okay, great. So we have ft over here. So now we're going to say ft is equal to ft. All right, so m1a plus fk plus fg parallel is equal to that m2g minus m2a. Okay, great. We're going to have to isolate all the a's. m1a plus m2a is equal to, we're going to send everything to the other side, m2g minus fk minus fg parallel. Okay, great. So acceleration is m1 plus m2. On the top we have m2g minus fk minus fg parallel. Okay, m1 plus m2, 2 plus 2, m2g minus fk mu k mg cosine theta minus mg sine theta. This m1, this is m1. Don't make those mistakes. 4, m2 is 2, 10 minus 0.1, 2, 10 cosine 30 minus m is 2, 10 sine 30. So acceleration is 20 minus 20 cosine 30 times 0.1 is 10 minus 1.7 divided by 4. So acceleration is 12, 8, 4. So acceleration is 2. Mr. Barry jumping up. Mr. Barry, who is 70 kilogram. Location A, location B, location C. This is B. What's going on at location A? Velocity is 0. Velocity is, we're going to find it out. Velocity is 0. Acceleration is 0. Acceleration we're going to find out. Acceleration is negative 10. The distance here is negative 0.2. Distance over here is 0. Distance over here is 0.8, let's say. Oh yeah, I think I gave you 0.8. So you crouch how much then? You crouch 0.2 meter. Then what is your jump height? 0.8 meter. Okay, so what are we going to have to find? Velocity here, velocity, acceleration here, and that will allow us to find the net force. Okay, so let's find the velocity. Vf square is equal to Vi square plus 2AD. Please understand that we're going to use location B and C. Okay, so then the information at location C, Vc square is equal to Vb square plus 2 ABACD. All right, and that is our then that be our jump height. We're going to call jump height H. This is crouching, and this is jump height. Okay, all right, so Vc is 0. Why? Velocity is 0 over here. I wrote it over here. Okay, VB, we are trying to find it, plus 2. Acceleration over here is -10. H over here is 0.8. Okay, so velocity at B is 4 meter per second. Okay, so we're going to update it. This is 4 meter per second. Now we're going to find acceleration over there. To find the acceleration, we're going to use the same approach. So this is step 1. This step 2. VF square is equal to VI square plus 280. Now you're going to use location A and B. So you're going to write location B square is equal to location A square plus 2 location B and location AB. All right, location B is 4 square is equal to location A is 0 square plus 2. Acceleration we are trying to find at location B. D is 0.2 because A to B is 0.2, as you see that. So acceleration is 40. So you're going to update it. Acceleration is 40. Okay, now step number 3. What are you going to do? Free body diagram. So this is Mr. Body at location B. This is mg. What does that mean? 70 times 10. So 700 Newton. Who is that? Mr. Body. And this is Fn. This is Fg. So number 4, F equal to ma. What direction? Y direction. All the forces. What are the forces? Fn minus mg is equal to ma. So Fn is equal to mg plus a. So m is 70, g is 10, a is 40. So 50. So 3 Fn is 3500. Many people wrote that, but this is normal force, not the net force, not what I ask you. So number 5, I don't know what I'm going to do. Let's do it here. Number 5. So here, now your Fg is 700 Newton, your Fn is 3500 Newton. So your F net is equal to F net. Okay. All the forces at the y direction is your F net. So 3500 minus 700 is your F net. So F net is 2800. You could be a very clever and save all the time by doing F equal ma, because F equal ma by definition F net is equal to ma. 70 times acceleration is 40, so 2800. I think I asked you for 260, so it's going to be 2.8 times 10 raised to 3 Newton. So problem number 4 is again 2 mass, right? But hanging on a rope is the easiest problem so far. So 2 mass, 1150 and 850. Let's call mass 1, let's call mass 2. Again, we're going to start our conversation with free body diagram. Is this 850, 850 and 1150? Okay. All right. So this one is M1G and this one is FT. Okay, that's it. That's all going on over here. This one is M2G. This one is FT. Okay, that's it. So what are we going to write? We're going to write FT minus M1G is equal to positive, because acceleration is this way, M1A. How are we going to write this one? FT minus M2G is equal to minus M2A. Why is that? Because acceleration is downward here. Okay, so acceleration, this one and this one, magnitude are same, by the way. A1, A2. A1 is equal to A2. Don't make mistake with that one. Okay, so now we have Ft over here, we have Ft over here. Now Ft is what? Ft is M1G plus M1A. What is Ft over here? Ft is M2G minus M2A. So you're going to say Ft is equal to Ft. So Ft1 is equal to ft2. Okay, so what is ft1? m1g is equal m1g plus m1a is equal to m2g minus m2a. So what's going on? m1a plus m2a is equal to m1g, no, m2g minus m1g. So a is equal to g m2 minus m1 over m1 plus m2. Okay, so acceleration is g is 10, m2 is 1150 minus 850 divided by 2000, 1150 plus 850. So I have 3000 divided by 2000. So I have 1.5. So ft is 1.5. So what is then tension? I don't know if I even ask you tension, but let's see. 1150. I don't know which one would be easier. Let's say this one is easier. ft is m1g plus m1a. So this is ft is m1 is 850, g is 10, so 850 times 10, 8500. m1 is 850 times 1.5. So ft is 9.8 times 10 raised to 3. I'm not sure whether I ask you for 2 sig fig, but there you go. Okay, let's say 30 degree. You apply a force 40 Newton, and there is a mu s 0.4, mu k 0.3. I think this is 10k, but not sure. Okay, so what's going on? What do we need to do? We need to find out the acceleration. How? By free body diagram. So let's see. Okay, let's draw the free body diagram. So fx, start with fx. Fx is fx fy 40 cosine 30 is 34.4, let's say 34.5, not sure what. 40 sine 30, which is 20, so this is fy, which is 20 Newton. Okay, this is fg is equal to 100 Newton because this is 10. This is fn 100 minus 20, 80. This is ff is equal to 80 times 0.3, 24. Okay, now 24, 34, this is 10, very nice. Okay, so let's make it 34. Or 34.5, so 35. Okay, all right, so what is the maximum? Fs, mu s, Fn. Mu s 0.4, 80. Okay, so 0.4 times 80, right? 0.4 times 80. Okay, so 32.0. So 35 is greater than 32. So the object will move. So the friction is 32 or 34. So we have to use 24 because 35 is bigger than 32. So we have to use 24 because this is 30. This is 24 and this is 32. Okay, all right, so let's go. F is equal to ma. So two forces acting on it, so 35 minus 24 is equal to m is 10 a. So a is 1.1 meter per second square. I'm not sure if I ask you for 2 sig fig, but there you go. 2 mass, this is 10 kilogram, mass 1, this is 2 kilogram, mass 2. There is a friction between mass 1 and mass 2, mu k is 0.2, and there is a friction between mass 1 and tab wall, mu k 0.1. By the way, be careful, this is mu s. Okay, so the first thing we're going to do, draw the free body diagram for M2. So M2 free body diagram goes here, M2. This is Fs, this is Fg, which is M2g. Okay, and this is Fn. M2g is how much? 2 times 10, 20 Newton. So this must be 20 Newton. Okay, great. So we're going to write F equal ma. At the x direction, what's going on? Fs only. What type of m is M2? M2a. We're done with this one. Other thing you notice that we can find acceleration over there. Let me remove the camera. Acceleration. How can we find the acceleration? Fs is mu s Fn is equal to m2a. Mu s m2g m2a. M2 cancel. Acceleration is mu s, which is 0.2 times g, which is 10. So acceleration is just 2. Wow, good number. So the mass 1, what's going on? Mass 1 is you have m2g, which is we already calculated it, 20 Newton. This is Fg. M1 is 10, so 100 Newton. So Fn is 120 Newton. Fs, Fk. Okay, great. So, F applied. So what is the applied force, maximum applied force, so that it doesn't slip? Moving with the M1, the M2. So F is equal to Ma. Fa minus Fk minus Fs is equal to M1a. Okay, good. Now Fs, we can replace Fs by M2a. So Fa minus Fk minus Fs is M2a is equal to M1a. So Fa is equal to M1a plus M2a plus Fk. What is Fk? Let's quickly find out. The normal force is 120. So Fk is 0.1 times 120. All right, so it's just 12. Fk is 12. So Fa is equal to M1, which is 10. Acceleration, we found it 2. M2, which is 2. Acceleration, which is 2. Fk is 12. So Fa is equal to 20 plus 4 plus 12. 36. Probably I asked you for 2 sig fig, but there it is 2 sig fig already. So many questions on 2 masses. Here you go, number 7, also 2 masses. Let's see. Mass 1, let's say 2 kilogram. Mass 2, let's say 5 kilogram. Let's say mu k on this tab wall of this tab wall is 0.1. Okay. Find acceleration. We're going to start with the free body. So this is M2g, this is Ft. So we're going to say F equal to Ma. We're going to say y direction. So Ft minus M2g is equal to minus M. This is M2 minus M2a. Okay, good. Now let's do this one. You have M1g, you have Ft, you have Fn, you have Ff. M1g is 20. So this must be 20 Newton. So 20 times 0.1, 2 Newton. So Ft minus Ff is equal to M1a. All right, so what is Ft? ft is equal to m1a plus ff. What is ft here? ft is equal to m2g minus m2a. Okay, so if we do ft is equal to ft, what do we get? M2g minus m2a is equal to m1a plus ff. So you have m2g minus ff is equal to m1a plus m2a. So a m1 plus m2 is equal to m2g minus ff. So a is equal to m2g minus ff m1 plus m2. A is m2, which is 5 times 10, minus ff is 2. M1 is 5, so 7. So 50 minus 2 is 48 divided by 7. So let's pretend like this is 49. So this is 7. Okay, now ft. So ft is m2 5 times 10 minus m2 5 times a is 7. So 50 minus 35. So 15, ft is 15, whatever it is. 5 in the morning, I'm not sure whether I should do number 8 because I did number 8 for the exam number 4. But the main idea I'm going to discuss, I did discuss it in the classroom. If there is a velocity v in this direction, and if you have if you swim, this is the velocity of the water. If you swim this direction, this direction, this direction, this direction, this direction, this one will take least amount of time because there is no x component over here. Y component is responsible for what? The time. So distance is vt. So d is d over v. So this is v at the y component. All right. So if the this is bigger, right, then the time gets small. Okay, this one will never go to the other side. Is because there is no y component over here. This one will take short amount of time because everything is y component. So I don't know, should I do the first part? Let's do the first part. So now this is 110 meter from south to north. You can swim 2 meters per second. The water moves 1 meter per second to the east. Okay, now the time it takes, again, how long does it take? So t is equal to d over v. So d is 110 and v is 2, so 55 seconds. All right, if you do this, because you're going to end it up downstream, but how much? D is equal to vt, 1 meter per second, and the time is 55. So it's 55 meter. So you're gonna end it up like right there. So this is from here to here is 55 meter. Okay, so this is the main idea of problem number 8. Okay, so now I have to do the reasons physics. There are 20 problems. We're going to try to solve each and every problem spending less than 1 minute. The problem number 1, you move 20 meter to the north, and then remember this one, this is north, this is south, this is east. So you move north is 30 degree. So 30 degree means there is a invisible x-axis. So this is 30 degree northeast. So then make it longer because this is double 40 meter. Now never forget to make it a parallelogram. So that's it, that's a parallelogram. So if this is 30, then that's 60, then this is 120, then this is 120, this is 60. So this is parallelogram. What are you actually looking to find? You're looking to find the resultant. This is the resultant. What is the resultant? That is r squared is equal to a squared plus b squared plus 2ab cosine 120. Parallelogram, you have to use the angle between tail and tail. So r squared is equal to 20 squared, which is 400, plus 40 squared, which is 1600, plus 2 times 20 times 40, and then cosine 120 is negative half. Negative 2 goes to 40, just 20. So you have r squared is equal to 400 plus 1600 minus, there is a minus, so you're going to put minus 20 is 400, 800. So r squared is equal to 400 plus 800. So r squared is 1200. So r is square root of 1200. So r is 34.64. So now I ask you to show me 2 sig fig. So you're going to show me 2 sig fig. 35 meter. This is the answer. If you want to write east, that would be great. That's problem 1. Now let's go to problem 2. Problem number 2. Let's first make a story out of problem number 2. You experience, you see, you observe 2 balls falling, hitting the ground with same impact velocity. 2 balls from 2 different height, one known and one is unknown. So this is the story of problem number 2. This is unknown, we're going to call it h, and this is known, we're going to call it 20 meter because we know it. This both initial velocity is known. However, the good thing is the both object hit the ground with same impact velocity. Final velocity is the same. So what are you going to write? VA square is equal to VI square plus 2AD. And the same thing over here, VB square is equal to, because this is ball A, this is ball B, VI square plus 2AD. Hopefully you see over there. So VA square is equal to, VI is given. All right, so you throw the ball with 20 meter per second, right, at 90 degree at the y direction. So you want to write 20 square, which is 400, plus 2 times, of course, negative 10, and D is now negative 20. So you have VA squared is equal to 800. Okay, so VA squared and VB squared has to be the same because the both ball hit the ground with the same impact velocity. So I'm just going to write VA squared is equal to VB squared. They are the same. So I'm going to write VA squared over here. But VI is given because you drop this ball. Drop this ball means initial velocity is 0, plus 2, negative 10. D is H. That's what you try to find, H. So VA squared is 800. So you're just going to replace it. 800 is equal to 20H. So H is equal to 40 meter. Okay, so we know now this is 40 meter. So in fact, this is double the height. All right, 2 kilogram mass. This is a motion of 2 kilogram mass. What's going on? I'm just going to show you the displacement versus time from, I don't know, from 0 to 6 seconds, because beyond I ask you information about 5 seconds. So I'm not going to go beyond 6 seconds. Oh, I totally forgot. I have to tell you the story. So the story is a 2 kilogram object is started moving, right? Fast 2 seconds, it moves with constant velocity. So let's convert my story to math. All right, fast 2 seconds, it moves with fast 2 seconds, it moves with constant velocity, right? 2 seconds, it moves with constant velocity, covering the distance of 2 meters. Next 2 seconds, it doesn't move at all. It is at rest. Next 2 seconds, it is at rest, covering nothing, covering no distance. And next 2 seconds, it is speeding up. Next 2 seconds is speeding up. So it is speeding up, So covering additional 2 meters. Next 2 seconds, we don't care because I ask you the information about the at 5 seconds. What is the net force acting on the object at 5 seconds? So we don't have to do 4 to 6. But if you want to do 6 to 8, then you know that at 8 the velocity is 0 because it's turning. So this is covering additional 1 meter. But we're not going to do beyond this one because I want to finish this tutorial as soon as possible. Now we know at 5, right? This is what I ask you right here. So we're going to convert this to VT graph. If we do convert to this VT graph, what do we get? This is diagonal line, so the slope of this one is velocity. So 2 divided by 2 is 1. Okay, so this is 1. All right, now this one velocity is 0 because the slope is 0. So we're just going to say the velocity of 2 to 4 is 0. So velocity is 0. This is 1, this is 0. So far so good. Now from 4 to 6 is problematic, right? 4 to 6, this is 4 to 6, this is 5. 4 to 6 is a curve, a positive curve. Positive curve means a slope of a positive curve is a diagonal line. The diagonal line, area of a diagonal line is half BH. So area is half BH. So what is area? Displacement. Half B, what is B? Time. What is H? Velocity. What is the D over here? 4 minus 2, which is 2. Half. Time is 6 minus 4, 2. Velocity. 2 to cancel. So velocity we discovered is 2. So you're going to write velocity, but it's going to be diagonal line. So you're going to put a dot over here, right? And we're going to draw over here, and we're going to put a 2, carefully put 2. Now we're done with converting the DT graph to VT graph. Now we're going to convert it to AT graph. And what are we going to discover by converting it to AT graph? We discovered that the slope of this one is 0. So 0 to 2 second, 0 to 2 second is the slope is 0. 2 to 4 second, the slope is also 0. But 4 to 6 seconds, slope is not 0. Let's see what is slope. The slope is acceleration is Vf minus Vi over Tf minus Ti. What is Vf? 1. What is Vi? 0. What is Tf? 6. What is Ti? 4. I'm sorry, 2. Or Vf is 2. So 2 over 2. So this is 1. Acceleration is 1. Now all about Newton's second law. Newton's second law is F equal to ma. F is equal to the mass is 2. A is we found 1. So F is equal to 2 Newton. Problem number 4. What is this story? This story is constant velocity. How constant velocity is this story? Because the net force is 0. Acceleration is 0. That's how constant velocity is a story. Not only one story. In problem 4, there are 2 stories. You have, I did not give you the mass in terms of kilogram. I give you the mass in terms of Newton. So that's in itself is a story. So I give you a mass, 100 kilogram, 100 Newton. So 100 Newton, you don't. This is not mass. This is weight, and this guy is moving. Applied force is 50 Newton. So there are 2 stories. Story number 1, it moves with constant velocity. So constant velocity means acceleration is 0. That means all the forces acting at x direction cancel each other. But do you see they cancel each other? No, you don't. Because now the way it does look, they don't cancel. It's not constant velocity. Why? Because there is a net force to the east. Now, to make it constant velocity, we have to cancel this one, 50 Newton. You're going to write 50 Newton. What are you going to call it? This is equal in magnitude, opposite in direction. What are you going to call it? Of course, FF. Okay, there you go. Now, another story is, I did not give you the mass, but I gave you the weight. I don't need to give you both. If I give you weight, you can divide by 10 and get the mass. So mass of this one, if you really want a mass of this one, divide by 10, acceleration due to gravity. So you get 10 kilogram, but you don't need it. This is Fg is 100 Newton because mass is 10 kilogram, and Fn is also 100 Newton. Okay, now what do you want to find? We want to find mu k. Now to find the mu k, you have 2 equations. Ff is FFS and FFK. FFS is mu s Fn and mu k Fn. Which one are you going to use? 50-50 chances? No, of course. The object is moving, so you have to use this one. So you're going to use FFK is equal to mu k Fn. What are you looking for? Mu k. So mu k is Fk over Fn. So Fk is 50 and Fn is 100. So that means mu k is 0.5. mu k doesn't have any unit because this one is Newton, this one is Newton. They cancel each other. And that is problem number 4. Now let's go to problem 5. The problem 5 is they come from the do now, right? You remember problem 5 came from the do now. What is that? You want to you don't like 9.8. Acceleration due to gravity negative 9.8 bothering you. Why is that? Because this is an ugly number. Why is that? Because this is decimal. Why is that? Nobody likes decimal. What do you want? You want acceleration due to gravity 10. Wouldn't it be nice to have acceleration due to gravity is just negative 10 meter per second squared? Okay, great. So what are you going to do? You're going to write F is equal to F. Then you're going to write Fg is equal to Fg. Then you're going to write Mg is equal to G M1 M2 over R squared. Why they are the same? Because hey, SI unit this one is Newton, 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 SI unit for this one is Newton, SI unit for this one is Newton. Now guess what? Is small m, I'm going to make it big M. Is small m cancel. Now you have G is equal to G big M over R squared. Now you want to change the mass, you don't want to change the gravitational constant or radius. So you want to write G is equal to big M. G over R squared, you don't want to change them. Still left hand side is equal to right hand side. Left hand side meter per second square, right hand side meter per second square. Okay, so G is, so we're going to say G, M, M. So we're going to say G old, G new, M old, M new. So what is G old? We know G old, which is negative 9.8. What is G new? We want negative 10. M old, we know 6 times 10 raised to 24. M new, we want to find it. Okay, great. So X is then what? 9.8, negative cancel. And you have 6 times 10 raised to 25. So X is 6.12 times 10 raised to 24 kilogram. What is X? New mass. All right, make sure you give only 2 sig fig. This time I was very nice and generous. Exam 5 on Friday, I won't be as generous because it takes forever for me to finish those grading. Right now, for example, it's 3 in the morning. So make sure I ask 3 sig fig, you give 3 sig fig. Okay, let's go to the next problem. Problem number 6. Problem number 6 is very simple. I give you, again, the studio problem 6 is, hey, I did not give you the mass, I gave you weight. But why do I have to give you mass when I give you weight? So what weight I gave you? I gave you 150 Newton. Okay, by knowing weight, you know the mass. How? Divide by 10. So the weight is 150 Newton. So mass is 15 kilogram. If you feel good by writing this one, feel free to do that. I don't care. I give you scrap paper. You write whatever you want. Good. You pull this one by 100 Newton and you pull this one by, well, there is a friction, by 50 Newton. So friction is falling this way, but there is a net force to the east because 100 is bigger than 50, obviously. Fg is 150 Newton and Fn is also equal in magnitude, opposite in direction. Good. What we are trying to find? Acceleration. Acceleration is Newton's second law. A is equal to F net over m. F net is 100 minus 50, 50. M is 15. So acceleration is 3.333 forever. However, I asked for 2 sig fig. I did not ask for 3 sig fig. 2 sig fig meter per second square. What is this 2D for problem 7? There is a box. You want to move, applying 15 Newton. Let's consider 3 scenario. Same box. Box with mass m. Box with mass m. Box with mass m. You apply some Newton. You apply some Newton. You apply some Newton. You apply 0 Newton. Velocity obviously going to be 0. Friction going to be obviously 0. You apply 15 Newton. and you realize that it doesn't move. So friction not going to be 0 anymore. Friction is going to be 15 Newton because it's opposing. Friction is opposing on the other direction. If you apply 20 Newton and you realize that box doesn't move, then of course the friction is 15 Newton, or 20 Newton. Friction is 20 Newton if box doesn't move. Okay, great. What is the studio problem number 8? What is the angle has to do with acceleration? If you increase the angle, acceleration decreases. If you decrease the angle, acceleration increases. Let's consider two scenarios. Scenario 1, scenario 2. A box, I don't know, 10 kilogram, make it up. Apply, I don't know, 60 Newton. FA is 100 Newton. 100 is a nice number at 60-degree angle. Same box, 10 kilogram. You decrease the angle from 60 to 10. However, you keep the same. So acceleration in this case is going to be 5, no friction. Acceleration is going to be 5 meters per second squared. In this case, acceleration is going to be double, 10 meters per second squared, or approximately double, very close to 10. So what do you see? Decrease angle, acceleration increases. Angle go down, acceleration go up. Takes us to problem number 9. What is this story? Story is I gave you 2 vectors and you have to do draw the parallelogram. Start from x and y axis. The vector A is 10 degree below the x-axis. The vector A is, not vector A, the resultant is, I don't know, also 10 degree above, more or less 10 degrees. So I'm going to erase this. I don't need this anymore. These are distracting now. So these help me to draw it. Okay, this looks too long. It should not be that long. So I ask you to show the B that causes this resultant. How? By parallelogram. Draw this vector A. So this is vector A. So draw an x-axis over here. And this is negative 10, negative 15. Who cares? Okay. All right. You don't need that anymore, x-axis. Okay, because you're done with the vector A. So you're going to call vector A or A prime. Okay, now you can draw B. So to draw B is this one. So this is B now. Okay, so this is B. So now you see that this is a nice parallelogram and this is the resultant. A resultant is from, when you see resultant is tail to head, then you know this is the resultant. So problem 10. So problem 10 is 600 Newton, apply 200 force. So 600 Newton who? Me. How am I 600? Because I'm 60 kilogram. What makes me 600 Newton? Because I'm a mass, force acting on me. 60 times 10. So 600 Newton. I'm 600 Newton. What am I doing? Applying some force. How much? I don't know. 200 Newton. I push this board with 200 Newton. Board applied 200 Newton to me. Equal in magnitude, opposite in direction. 11. 2 Newton box is resting. Friction graph is given. Some information is given. Okay, so what do you know that this is mu k? What do you know that this is mu s, this is mu k fn. This is mu s fn max at right here. Okay, anyway, so the box is resting, right? Some force applied to the box and the box is moving. Find the mu k. To find the mu k, of course, you're going to do what? F is equal to ff is equal to mu s fn mu k fn, right? You know the box is moving means you have to use this one. When you use this one, what do you get? Mu k is equal to ff over fn. So now if this is 2 Newton, this is 0.2 kilogram, by the way. 0.2 kilogram times 10 is 2 Newton. So Fg is 2 Newton. Fn is 2 Newton. So Ff is 0.9, and Fn is 2. Okay, is 0.67, mu s is 0.85. So this dry asphalt is like a concrete. Okay, so the driver hit the brake. When the driver hit the brake, what happened? Wheels, the friction acting on the wheels, right? And friction slow it down, and eventually the car is stopped at location B from location A and is skidding, right? Is stopped right here with final velocity. And initial velocity was not 0. After hitting the brake, initial velocity eventually at location B get to the 0. And the distance from A to B is 16 meters. We don't need that. We want to find out friction that causing this halt. So the friction that causing this halt, so FF is equal to FK Fs, right? So this is mu s Fn, and this is I don't know mu k Fn. So this is the car, right? 1200. So this is 12,000. This is Fg. This is Fn, also 12,000, right? Equal in magnitude, opposite in direction. Okay, so now the car was moving while it was slowing down and stopping. So we have to use mu k, not mu s. So ff k is equal to mu k Fn. Okay, so then f is mu k is 0.67, right? 0.67 times normal force. What is the normal force? 12,000. Okay, so I ask you to give me in 1 sig fig. So 8 times 10 raised to 3 Newton. Okay. 8 times 10 raised to 3 Newton. I asked you to give me sig fig. So this is 1 sig fig. Okay, 1 sig fig. Follow the direction. Let's do problem number 13. Problem number 13 is G is, if you write G is negative 9.8 meter per second square, I'll mark it wrong. What is that? Because this is not what I was looking for. This is not what I asked. I did not ask you to give me acceleration due to gravity. Of course, this is very close to what I asked for, G, okay, which is negative 9.8, which is Newton over kilogram. So you can say this is almost the same. Okay, almost the same and same are not the same thing. So this is the convention. We have to follow the convention. So let's follow the convention, and so let's strictly follow my instructions. Okay, now do you have to memorize it? No, you don't. Did I memorize it? No, I don't. Okay, so let's derive it. So what do you call it? Gravitational field. So when I write G is equal to negative 9.8 meter per second square, this is acceleration due to gravity. This is called acceleration due to gravity. When I write G is equal to negative 9.8 Newton over kilogram, this is not acceleration due to gravity. This is gravitational field. Where did the equation come from? Here, F is equal to F. Nothing can go wrong with that. Fg is equal to Fg. Also nothing can go with that. Mg is equal to G, big M is small m over r squared. Also nothing can go with that, because this is Newton, this is Newton. Cancel. So G is big G, big M over r squared. How do you know this is meter per second? This is Newton over kilogram. This is Newton over kilogram. You know it. This is Newton. G is Newton. Meter square over kilogram square. And then you have meter mass, which is kilogram. You have r squared, which is meter square. Now, if you look inside the Newton, you see kilogram meter per second square, being down meter square, being down kilogram square, and being down meter square. And you want to see lots of things going to cancel out. Meter square cancel. Kilogram goes to kilogram square just once. So what are you going to have? You're going to have kilogram meter on the top. On the bottom, what do you have? Kilogram second square. Kilogram second square. Now, kilogram meter per second square itself is a Newton. So Newton over kilogram. There you go. So we prove that. Okay, in the future, we're going to prove that this is actually 9.8. In fact, you can prove it right now at home. So G is 6.67 times 10 raised to negative 11. m is 6 times 10 raised to 24, and r is 6370000 square. So g, this is 9.8. We proved that. Okay, there you go. That was problem number 13. Let's go to problem 14. So what is this today? Problem 14. I ask you construct a parallelogram. All right, so you're gonna go 20 Newton. I don't know what I gave you, but let's say I gave you 20 meters. Doesn't matter. All right, so then you're gonna draw an x-axis and 60 degree with respect to x-axis, right? Because I said this is north, this is east. So I said move northeast 60 degree. So move. All right. So this is 40 meters. Okay. So this is vector B. So this is vector A. This is vector B. So what is A prime or B prime? Let's draw B prime. The B prime would be this one. This one would be B prime. Okay. If you have the x-axis over here, this is 60 northeast. Okay. And this is your A prime. A prime, this is your B prime. So this is the resultant vector. Now if this is 60, don't forget this is 30, right? Because 30 and 60, 90. Then this must be 150 because 150 and 30 is 180. And then this must be 150 and this must be 30. And this must be resultant. Okay. All right, there you go. So that is that. And that is problem 14. Let's do problem 15. Problem 15 is, what did I ask you? I asked you is similar to problem number 3. I gave you the DT graph. The DT graph 1, 2, 3, 4, 5. The time measured in second 1, 2, 3, 4, 5. This is 2, this is 4, this is 6, this is 8. So something going on in this graph, right? So 2, so at 2 seconds the object move 4 meters. Next 1 second object at rest. Next 1 second object is speed up or slow down. Next 1 second, all right, so it's speeding up and slow down. Okay, that's what's going on. This is the maximum velocity, and that's all right. This is speeding up again. Okay, all right. So velocity here, speed here, speed here. The same. Okay, so now you're gonna do a VT graph. How do you do it? Okay, you're gonna do it by doing it. 4 divided by 2 is 2. So this is 2. Now you see the slope of this one is 0. So you're just gonna draw 0. You see the slope of this one is a diagonal line, but this is, yeah, what happened this one? This is max and decreasing 0 and increasing. Okay, well the magnitude is increasing, but the velocity is decreasing, speed is increasing, whatever that means. Okay, so the displacement, what is the distance? From 3 to 4 is 4, and from 4 to 5 is 4. 4 plus 4 is 8. So this is a curve. So curve gonna give you a diagonal line. If the curve does give you a diagonal line, then diagonal line is, you did it million times. A is equal to half BH. So 8. Why 8? Because the distance from 3 to 5 is 8. 8 minus 4 is 4, and 8 minus 4 is 4. So here is 4, here is 4. So 8. Half. It move 8 meter spending 2 seconds. So velocity is 8. If velocity is 8 over there, velocity must be 8 right here. I mean negative 8. Okay, good. So if this is negative, this is positive 8, this is negative 8, because this is symmetric. Good. We're gonna find this VT graph, what you call it, the slope. So the slope is, acceleration is VF minus VI, TF minus TI. So VF is negative 8, positive negative 8. Delta T is 5 minus 3, 2. So negative 8. Acceleration is negative 8. So the slope of this one is negative 8. That's what it means. So we're going to write y is equal to mx plus b. The most important point is 4, 8. No, absolutely not. We're not going to use this graph. We have to use this graph. Okay, so the point, any point you can take, this point you can take. At 4, the velocity is 0. So 4 comma 0 is a nice point. Okay, so this is x, this is y. So y is 0. When y is 0, of course, the slope is -8. X is 4 plus b. So we know y-intercept is 32. Now we know everything. So y is equal to mx plus b. So y is equal to -8. This is t plus 32. So this is v of t, not p of t, because we use this graph, and this graph is vt. So this is v of t. If we did use this graph, then it would be p of t. Now we use this graph, so this is v of t. So this is -8 t plus 32 at 4.5. I ask you 4.5. So -8 4.5 plus 32. So this is v of t is equal to 36, -36 plus 32. So this is -4 meter per second, of course. So problem 16 is the most important problem. Why is that? Because it allows you to make connection between 4 different things. You want to see the connection between force, acceleration, velocity, and displacement. 4 simply different things. You're going to put them together by using problem number 16. All right, so what is that? You have a 20 kilogram object, 2 forces acting on it. Force A, which is 100 Newton. Oh, well, I can do it better. I can say this is at t is equal to 0, there is a box which is 20 kilogram. There is a force acting. A is 100 Newton. And there is a force B, which is all 120 Newton at angle unknown. And at t is equal to 0, the displacement is 0. Now, the box at t is equal to 3 seconds over there, that means d is not going to be 0. In fact, d is happen to be 5. The mu k is 0.1, right? I want you to find what angle made this 5 meter possible. It's seemingly very easy problem. It is actually easy. All right, so step 1, we're going to write ax, ay, bx, by. Now you pause the video and do that. Okay, so ax is 100. Ay is 0 because A doesn't have y component. B has x component and y component. So 120 cosine theta and 120 sine theta. Step number 2, we're going to draw a free body diagram. Free body diagram, the easiest thing always is the weight. The weight is 200 Newton. Why is that? Because it's 20 kilogram. Fx is, you want to add them up. So 100 plus 120 cosine theta. Now, Fy is, you want to add them up. 120 sine theta. Normal force, 200 minus 120 sine theta. Don't forget to call it normal force. FF is mu k Fn. Mu k is 0.1. Fn is this one. So 200 times 0.1 is 20 minus 120 times 0.1 is 12 sine theta. You're done with free body diagram. Now you always gonna, once you finish the free body diagram, you use Newton's second law. 3 F equal to ma, Newton's second law. All the forces acting at the x direction. Okay, we're gonna call F net because ma is equal to F net. Fx, so F net is equal to Fx minus Ff. Okay, so what is Fx? 100 plus 120 cosine theta. 100 plus 120 cosine theta. Minus, so this is minus. Minus, you see that 20 minus 12 sine theta. You notice I made a mistake intentionally to kind of put emphasis on forgetting about distributing the negative sign. Okay, so this is our F net. So acceleration is F net over what? Mass. Mass is 20. F net is 100 minus 20 is 80, plus 120 cosine theta, plus 12 sine theta. Now, acceleration is 80 divided by 20, of course, 4, plus 120 divided by 20 is 6 cosine theta, plus this is 0.6, 12 divided by 20 is 0.6 sine theta. This is acceleration. We're going to do step 4. D is equal to half a t squared. Now, at 3 seconds, so D is equal to 4.5 a. Now, step 5, we know that 4.5 a is equal to D. So 4.5 a is 4 plus 6 cosine theta plus 0.6 sine theta is equal to D, which is 5. It's 2.7. This is 27 cosine theta plus 2.7 sine theta is equal to 5. So this is our step 5. Now we're going to go to step 6. To go to step 6, I'm going to take you over here. All right. So step 6. Remember, step 5 is this: 27 cosine theta plus 2.7 sine theta is equal to negative 13. Okay, so we're going to write dot product u dot v cosine theta minus p is equal to negative 13. What is going on over here? You probably think. Let me bring it closer. What is going on over here? You probably think. Well, let's explain what's going on. U is 27 comma 2.7. So the angle for this one is the theta is we're going to call it P. Let's call it P because we have two angles going on over here. P is tangent inverse 2.7 divided by 27. 2.7 divided by 27. So P is 5.7 degree. All right. Okay, what is V? V is cosine theta comma sine theta. Okay, so what is the magnitude of the V? The magnitude of the V is 1. How it is 1? Because cosine squared theta plus sine squared theta is equal to 1 in the unit circle. Okay, so the magnitude of V is 1. What is the magnitude of U? 27.13. Okay, great. Now, we're going to write V, U, and that is step 6. Dot V, okay, cosine theta minus P is equal to negative 13, right? So you're going to write U is, we found it, 23.13. V, we found it, 1. Cosine theta minus mu, phi, 5.7. Okay, so cosine theta minus phi is equal to negative 13 divided by 27.13. So theta minus phi is equal to cosine inverse negative 13, 27.18, 13. So this is 118. So the theta is then 118 plus 5.7. So this is 124.33. I asked 3 sig fig. So theta is 124. What does that even mean? Okay, let's see whether I can give you some intuition. If you go to unit circle and you draw, this is x, you draw u, where did I get u? Okay. What is x between x and u? Phi. What is phi? 5.7. What about v? This is v. What is the magnitude of v? What is the magnitude of u? Magnitude of u is 27. What is the magnitude of v? 1. Okay. All right. Now we can find the angle, right? What is the angle? Angle is 118. So what is the angle from the vector A to vector B? 5.7118. See, we put them together nicely. 17 and 13 are the same thing. All right, so this is the gravitational field. The magnitude of gravitational field is 9.8, and the SI unit for gravitational field is Newton over kilogram. I proved it before, so I'm not going to prove it again. Check problem 13. I show you the proof where Newton over kilogram come from and where 9.8 come from. Problem 18, I give you, so there is a rope. This is ceiling. This is rope 1. This is mass. This is rope 2. So you're going to draw. What I did, I apply some force downstairs. I grab it, I pull it down with 5 Newton. It's spending forever. Spending forever means that rope 2 was able to communicate with mass, was able to communicate with R1, and the breaking point, rope breaking point, is 6 Newton. The question is, you're going to draw a free body diagram and which rope will break. Very easy. Let's start with rope 2. Rope 2, okay, there is no mass to the rope. There is a mass, but almost zero, so we don't care. FG, there is no FG, so F pole is negative 5 Newton. So this was able to communicate with the, it was able to send the information. So F, we're not gonna say Fn, Ft, the tension force, okay? You pull it down, there is a tension. If you pull it down, there is a tension on the rope. If you pull it down, you will see the tension on the rope. That tension is 5 Newton, positive, because it's opposite direction. Okay, we're done with the rope 2. Rope 2 did not break because this is not the limit. Okay, so you're gonna now do mass. All right, mass, what's going on? Mass is Fg. Fg is, mass is 200 gram. So it's 2 Newton, negative. Pole, F pole is this one, actually, is 5 Newton, negative 5 Newton. So you're going to say this one, Ft, is 5 plus 2, 7 Newton. Of course, opposite direction. Okay, now what happened to the rope 1? So we're going to go to rope 1 now. Okay, and the rope 1, Ft or F mass or whatever you want to call it, Ft from mass, negative 7 Newton. F ceiling or whatever you want to call it, Ceiling, ceiling, is positive 7 Newton. Now wait a minute, this is finishing the free body diagram, allowing us to see that this rope did not break, but this rope broke because 7 is bigger than 6. So this rope snaps. Okay, that was problem number 18. Let's do problem 19. So what happened? You are on the top of a 50-meter cliff. What do you want to do? This is 0 meter. So this is 50 meter. You are on top of here. You are here. You want to jump. Not here. Not here. Not even here. So here is 90 meter. So here is, let's say, 40 meter. Here is 100 meter. So you don't want to jump. You don't want to land at 40 meter. You don't want to land at 100 meter. You want to exactly land at 90 meter from the wall. So how can you solve it? You know that right here, when you off the rooftop, the velocity has two components, Vx and Vy. Vy is 0. What Vx will allow you to land at exactly 90 but not 40 or 100. So d is equal to dx and dy. Dx is Vixt and dy is Viyt plus half a yt square. This one goes to 0. So this one is 50 or negative 50, and this one is 5t squared. So negative negative cancel. 5 goes through, so t squared is 10. So t is square root of 10. All right, so it's 3 something. So then you want to find this one. So Vx is what? Dx over t. So Vx is now, dx over t. Do we know dx? Yes, 90. All right. Do we know t? T is square root of 10, which is 3.2. I don't know. So 90 divided by 3.2 is 28 something. But I ask you for 2 sig fig. So 28. 28 what? Meter per second. So you have to leave the rooftop with Vx 28 meter per second. So you don't land here, you don't land there, you land here. Okay, the last problem, 20. Thank God, it's 4 in the morning. Okay, all right, so 20. Okay, 1, 2, 3. I gave you 3 scenario, but the good thing is you see 3 balls falling. Okay, 1, initial velocity is 25 meter per second, 90 degree. 1, initial velocity is 0. That means it is dropped. 1, initial velocity is Vi is negative 25 meter per second. That means it is throwing down. This one height is I don't know, 30. This is 180. This is 330. The good thing is they all fall at the same time. Okay, so T1 is equal T2 and T3 is the same thing. So which one would be the easiest to find? This one would be the easiest to find because it's free fall, it's drop. So if you know T2, you know T1 and T3. There you go. So you can find T2. How can you find T2? D is equal to half a t squared. D is 180 is equal to 5t squared. 5 goes to 180. 3, so 36 t squared. So t is equal to 6. So t1 is 6, t2 is 6, t3 is 6. Answer is 6. That was 20. Very easy. I'll see you tomorrow. Well, today. It's 4 in the morning.